So all bonds fall into one of two categories. The two categories depend on sort of what happens to the electrons in the bond. In one type, you have electron transfer, and in the other type, you have electron sharing. Okay, so if there's an electron transfer that occurs, like literally one atom gives an electron to another atom, this is called an ionic bond. If you have electron sharing, aka two atoms sort of share an electron with each other, right, this is called a covalent bond. Right? This part is super important, and that's why I put it first. Okay, you need to remember that ionic bonds are electron transfers and covalent bonds are electron sharing. Ionic bonds occur between a metal and a nonmetal. Oftentimes, if you get a question about sort of like what type of bond is between these two atoms, easiest way to do it is usually just to look at the atoms themselves and be like, oh, well, is that a metal and a nonmetal, or is it a nonmetal and a nonmetal? If it's two nonmetals, it's going to be a covalent bond. All right. Other thing to note, so for example, let's say, right, since there's electron transfer going on in here, let's say, for example, Na, which is a metal, is going to get with chlorine, which is a nonmetal. So together, this guy is going to sort of donate an electron over to chlorine, and what you're going to get is a sodium ion and a chlorine ion. Okay, these are real charges that exist here. All right, these charges exist because this guy has literally lost an electron, and chlorine has gained an electron. What ends up happening is that these are opposite charges now, and they're attracted to each other, so they form a bond with one another. So normally you would draw NaCl like that, and we would say, oh, well, that's clearly an ionic bond because it's between a metal and a nonmetal. But that ionic bond is really just an attraction that occurs between two oppositely charged ions. Over here on the covalent side, you can get into a little bit more detail. There's actually two types of covalent bonds. There's polar bonds and nonpolar bonds. I can tell you that the polar bonds are going to be much, much more common. And since these electrons are being shared, like let's look at water, for example. So you draw water here, right? These are covalent bonds. We've got two nonmetals here. So this is one covalent bond. This is the second. Polar bond is a result of an unequal sharing of electrons. A nonpolar bond would be the opposite. You have equal sharing. So what this has to do is with sort of each atom's individual desire for electrons, right? Like oxygen, oxygen wants electrons much more than hydrogen, and you might be familiar with this term like electronegativity, which is the desire for electrons. If you're not, like whatever, it's not that big of a deal. Just note that, right, some atoms might want electrons or pull harder on electrons than other atoms. In this case, the oxygen pulls way harder than the hydrogen. So what ends up happening is that even though they're sharing electrons in this bond, the electrons are sort of like going to be over towards the oxygen from both of these bonds more than they would be towards the hydrogen, because the hydrogen can't pull as hard. You could look at it as sort of like the oxygen bullying the hydrogen or whatever. And what you get is something called, and I'm going to use the symbol delta, a partial charge. So this hydrogen is like kind of positively charged. It's not fully positively charged because it hasn't lost an electron. It's partially positively charged because it's like, you know, it hasn't lost it, but the electron's not going to be around it as much as it's going to be around the oxygen. And so the oxygen's partially negative because it has electrons. It's almost as if it stole one, but it's not fully there yet. So that's another thing to remember. These ionic bonds involve full charges. Right, and then these covalent bonds, or specifically polar covalent bonds, involve partial charges. So when eventually you learn about intermolecular forces, this is going to make a difference. But nonpolar covalent bonds have no charges. And they have no charges because, I mean, the electrons are shared, you know, right in the middle. They're shared equally, and so there's no transient charge. The electrons just kind of sit right there in the middle. It's like you're playing tug of war and the rope's not going anywhere really. Okay, so no charges for the nonpolar. Polar is unequal. And remember, covalent is going to be electron sharing. If you remember anything, remember this, and remember this part. the electron transfer, right? So ionic bonds, electron transfer, metal and non-metal, two nonmetals here.